Hello. So a key question in options trading is computing the future price of an option as the stock price changes. I've made one previous video about the Derman sticky delta model to accomplish this task. But it's a simplistic model. And in this case, I'm taking more of a data mining type of approach. So here's a scatter plot of daily changes in the price of the SPY on the x-axis versus daily changes in the implied volatility. So I mined the historical options data over the most recent 100 days, and the scatter plot includes all options with all days to expiration and all moneyness within a plus or minus 20% of $20 of the stock price. So before I go any further, where did I get the raw data? I have an account at ORATS, which is an awesome site for options data and analysis. So they offer subscriptions to an API where you can grab historical options price data for only 29 bucks a month. So very reasonable. They also have a trading platform with some really serious analytical tools. I haven't dug into that yet, but I'd like to. So anyway, Google ORATS API Explorer, and you can test out the API. So the scatter data actually follow a fairly linear trend, and the linear trend makes sense intuitively. So if the stock price rises, then we expect to see a drop in implied volatility and vice versa. So the slope of the line in this case, I just drew a line, is about minus 0.0025. So what it means is, as you change, as the stock price increases by $1, then the IV drops by 0.0025. So this scatter plot was created using all the available options from 1 day to expiration out to 100, and from $20 out of the money to $20 in the money. So what if we use a subset of the options instead of all the options? So in this case, I repeat that calculation for options that are 10 to 20 days to expiration, and those with a strike that are within $5 of the stock price, plus or minus. So notice that the slope of the line steepens. So what this is saying is that the sensitivity of an options IV with respect to changes in the stock price is variable. It depends on the days to expiration of the option and how far in or out of the money it is. So I kind of generalized this. I wrote a program that computes a straight line fit for all the strike prices and all the days to expiration over the same 100-day period. And there's a lot of structure in the data and a lot of variability in the data. Just look at the color bar. It varies from minus 0.002, about 5x, up to about in excess of 0.01. So there's like a 5x variation in the sensitivity of an options IV to the stock price, depending on the days to expiration, depending how far in the money it is. Pretty interesting stuff. Okay, so everywhere the slope values are negative. So that means, as the stock price increase, IV falls, and it makes sense. So the blue region are areas that are the most sensitive options, and these are at the money and in the money calls that are very close to expiration. So the slope in the blue region is about minus 0.01. So to make it concrete, if the IV of one of these options today was 20%, and the stock price went up by $10 today, then it means that the IV tomorrow would drop by 10 times minus 0.001, or all the way down to 10%. So it makes sense. A huge move up in the stock would mean that a near the money, near expiration option could be very sensitive. The IV would fall precipitously. So a more realistic example is the circled region here, which is kind of puke green. So it's a slope of about minus 0.003. So this is like an at the money call with about 50 days to expiration. So if the IV of that option today was 20% and the stock price increases by $10, then the IV tomorrow would drop by 10 times minus 0.003 or minus 0.03. In other words, the IV would fall from 20% down to 17%, and that intuitively seems reasonable. So obviously this is a pretty simple approach, but I like the fact that it gets the direction right. And it's probably in the ballpark to predict the magnitude of an IV change as the stock price changes. And it's cool to see that there's a lot of this variation. So you could apply just one correction value. I could use all the options to compute one single straight line and use it, and that would give me a slope. But it would be off in some places, especially as you get closer to expiration, when the sensitivity of those options really increases. So why I'm doing this, I'm aiming to improve the accuracy of my Black-Scholes modeling. So as the stock price changes, I want to be able to understand the IV accurately, because the IV is essentially what drives the option price. So it's going to help my Black-Scholes model kind of more accurately predict the profit and loss as the stock price changes with time. So unfortunately, this has gotten too computationally intensive to be done in a Google Sheet, even using the apps script, kind of the Visual Basic thing that Google has. So I have to program it in a more basic language. So I like to use Fortran 90. Most people prefer C or Python these days for scientific programming, but I have a significant amount of legacy code in an environment in Fortran 90, so for my day job, so I like to use it. So anyway, this is kind of a technical video, but I know there's some of you out there who are into this kind of stuff. Just slowly building up my analytical tools and building up my understanding to see if I can, get if not an angle, at least a deeper understanding of how options behave, and hopefully trade it. So anyway, let me know what you think, and if not, I'll see you next time.